Hi everybody, my name is Mr. Walrath. Sorry I can't be with you in week 1. I'll be with you next week. And we're going to make up some of our time by me posting some videos to YouTube and you watching them and you sending me an email saying that you did in fact watch them, and I will mark you present for the day. So please try to get that email sent to me by, let's say, Thursday, Friday maybe, so I can put it in by Saturday. As soon as I get that, I will mark everybody in there and we'll have attendance taken care of. Next week we will go over the syllabus and all that good stuff and where to find your assignments and where to take your quizzes and all that kind of stuff. But to make up for some of the time, we are going to go through some of the notes that we would normally go through in class. And normally anytime that I write things down in class, I'll post them to a PDF file that you find in the course documents under that appropriate week. So today we're going to focus on the metric prefixes and working with conversions within those metric prefixes. And we'll see if I can get this thing to work properly. I've never done this before, so please be patient with me. So the first thing we're going to look at is what are some basic metric prefixes and why do we use them? Why do we care about them? Why can't we just use the English system like we've always used? And back in the 70s, Jimmy Carter actually tried to convert us into the metric system. And he only tried it for about a year and didn't seem to go over all that well. People wanted to stick with the old antiquated system rather than moving to the system that the rest of the world uses. So the metric system is much more user friendly if you just get used to it. And that's because it goes up and down by basic units of 10. And all we got to do is put some type of prefix on our basic units, and by basic units we're talking about things like meters, liters, grams, so on and so forth. Those are our basic units. So we can form larger or smaller base units by basically putting prefixes on the front of those basic units, like I've done right here and right here. I put kilo on the front, that changed its value to 1,000 meters. Put kilo on the front of grams, that changed it to its value of 1,000 grams. So we're going to look at prefixes that are going to increase the value of our base unit. And we're also going to look at prefixes that are going to decrease our value of our basic unit. Got to get used to this annotation. I don't use this very often. So the prefix here, the symbol here, and the value here, going straight down in all groups. Giga is a very large prefix. Okay, it's symbolized by the capital G here, and its value is 1 billion, like Dr. Evil would say. So writing that in scientific notation, it would be a number times 10 to the 9th power, or your calculator might spit that out to you as e to the 9th. Mega is a lottery game that I play that I haven't been successful on. I hope that changes someday. But Mega, its symbol is capital M, and it stands for 1 million, or a number times 10 to the 9th power. And your calculator again might spit it out as e to the 6th. Kilo is one that we saw in the previous slide. It's a lowercase k here, and it stands for 1,000. So somebody might say 1 kilogram is equal to 1,000 grams. You could say something like that for hecto as well. 1 hectogram is equal to 100 grams. And 1 decameter is equal to 10 regular meters. Those are prefixes that make something larger. Now we're going to take a look at things that might make something smaller. And here they are, the prefixes going straight down, the symbols going straight down, and the values going straight down. So deci, symbol is a little d. If you like fractions, it would be 1/10 of a meter. Centi are the numbers on our meter sticks. We'll see those when we get to class. In week 2, and that stands for 1/100th of a meter. Milli is 1/1000th of a meter. Micro, that's a symbol right here. It's actually a Greek letter called mu. not the Pokemon Mew. That's spelled like this. This is Mew. If you have kids and know what Pokemon are, that is 1/1,000,000th of something. Nano is, as far as we'll probably go, nano is symbolized by a little n here, and that's 1/1000,000th. I gotta go underneath here. 1/100000th. And your calculator might spit these out as e to the -6 or e to the -9. Pico and femto are smaller as well, and if you look on the internet, I'm sure you'll find more that either go below these or some that exceed the value of what we had in the previous slide. There's a laser pointer too. Alright, so those are things that are going to increase or decrease our basic units. There we go. So again, take a look at these. Pause the video, see if you can select the most appropriate thing to measure these different items. Okay, again, welcome back. Your height should have been measured in meters. Your mass should have been measured in kilograms. The distance between two cities, if you've ever driven through Canada, you'll know that those are measured in kilometers. And the width of an artery, very, very small. We want millimeters for that. Answers are usually on the next slide, and there they are. And our last learning check here for us, we're trying to figure out what prefix would we use to describe the same thing. So take a look at the description. Mass is 1,000 times greater than 1 gram. 1,000 really means kilo. A length that is 1/100th of 1 meter. So small, this is 1/10th, this is 1/100th, this is 1,000th. And a unit of time that is 1/1000th of a second. That is a very small time, not these small, but this small right here, millisecond. Here's our answers. And what we're going to spend a little bit of time doing is converting between different units. It's easiest to do within the metric system, but right here this is relating the English system to the metric system. So what we're going to be doing is building some conversion factors from this. And if we were to scale this down to 1 inch, just move your decimal over one time, 1 inch is equal to 2.54 centimeters. So that's known as the equality. Some people might call it a conversion factor. And what we're basically going to be doing is we're going to be making two fractions out of this, and we're going to be using them to convert between inches and centimeters. So we could set this up with inches on top of our fraction like this, 2.54 centimeters. Or we could flip it around and put 2.54 centimeters on top all over 1 inch. So what I might ask you to do is convert, say, 2.5 inches into centimeters. And I don't want you to use rulers here. I want you to use some dimensional analysis that will allow you to cancel units to figure out what your answer is. So we're going to be setting up lots of these little bridges, is what I like to call them. So we're going to put our given 2.5 inches on top of this bridge, and we're going to have a bridge over here that's basically consisting of one of these two conversion factors. The one that you want to pick has inches on the opposite side, so it'll go down here. And hopefully by a quick inspection, you'll see that this is the one that has inches on the opposite side. So copy it down exactly as it appears in the fraction above, and hopefully you will notice that inches cancel out because they're on opposite sides. They cancel, and now it's just number crunching in your calculator. Multiply 2.5 times 2.54, and you're going to come up with 6.35. and you should always include the unit that's left there. I'm running out of room there, so 6.35 centimeters. Let's try another one up here. Let's say we were working with 12 centimeters. Now I want to know how many inches is that. So again, build your bridge, 12 centimeters. Here's your given. That is always on top of your first bridge, and the second bridge is going to be your conversion factor. These are the two conversion factors, and the one that you want to select is the one that has your given unit on the opposite side down here. So that would relate to this one right here. So put 2.54 centimeters on the bottom, 1 inch up on top. Okay, again, centimeters and centimeters cancel. Now you would multiply across the top. You get 12 times 1, which is 12, and then divide by anything on the bottom. So 12 divided by 2.54, it's going to give us 4.7 or so. Again, I can't write over here, so I'm going to just include the units down the bottom. That is 4.7 inches. Hopefully you're getting a little bit more familiar with this. It's all about canceling units and making sure that units are on opposite sides so that they cancel out. So here's some metric equalities, and these are basically what we just did, and I'll show you a shortcut in order to do this after I show you the dimensional analysis way. So 1 meter is equal to 100 centimeters. So if you had something like 25 meters and you wanted to know how many centimeters, that was. That should be a question mark. We would want to set up our equality the same way. Again, you can make conversion factors out of this. 1 meter over 100 centimeters, or you can flip it around, 100 centimeters over 1 meter. Now we're going to build our bridge here, 25 meters, and we want to put it in such a way that meters is on the opposite side. So hopefully you can see that you would select option number 2 here, 1 meter and 100 centimeters on top, meters opposite sides, they cancel. Putting my work down here at the bottom here, I would end up with 2,500 centimeters. Now there's another way that you could do this, and some of you may know this or have heard different acronyms for it, but this is the one that I like. King Henry dances merrily during cold months. So this puts our metric system in order from 1,000 to 1,000. This is 1,000, 100, 10, 1, 1/10, 100th, 1,000th. So King Henry dances merrily during cold months. In my previous example, I was starting at meters. Okay, and I'm going to put my pen right here, and I needed to get over to centi, which is right here. Okay, make sure you know that this one is meters, this one is millimeters. There's 2 M's, so don't get confused there. 25 meters. I'm going to take my decimals, and I got to get over to here, so I'm going to move my pen once, twice, in the same direction. So I started with 25. Here's my decimal. I move it just like I did my pen. I move it once, twice, to the right, once, twice. There's my new spot, and I add zeros in now. Now I'm not in meters anymore, I am in centimeters. So 2 different ways. This is why we use the metric system, because it's very, very easy to convert from one unit to another. Much easier than the English system. Much less memorization than the English system. So take a second, let's see if we could do some of these. And we could do it any way you want. Okay, since it's a metric system, I'm going to use the easy way in just a second. So pause the video, try these problems, and then come back after you think you have answers to them. Okay, welcome back. I'm just going to put our King Henry dancing merrily during cold months up on top. We're starting in meters, or 1,000 meters, and we want to get to 1 of something. So I'm going to move it 1, 2, 3 times, and that's equal to 1 kilometer. So I would pick number 2 here. 0.001 grams. And converting this into 1 of something. Okay, I got to move my decimal 1, 2, 3 times, and that would be 1 milligram. So move to 1, 2, 3. Now is it grams? This could be grams. It could be liters as well. So getting it to 1, 1, 2, 3. That would get me there. Next one, move my decimal 1 time to the right. So I'm at liters, move it over here, and I would be at number 3. This one I have to move my decimal once, twice to get it into the 1 spot. Notice my decimal is right here. So I moved it twice. I was at liters. I'm sorry, I was at meters rather. Moved it once, twice, and that would be number 2. Hopefully I got those right. One last learning check for you. See if you can use your King Henry dancing merrily during cold months to figure this out. So pause the video and then come back. See if you got the right answers. Okay, welcome back. Okay, 1 kilogram. We need to get it over to grams. So we're here, 1, 2, 3 spots to the right, and that would be number 3. Millimeters into meters. 1, 2, 3. That would be number 1. Alright, hopefully you did well on that. We'll practice more of these when we get back to class too. Here's some more that if you spend any time in the kitchen, you maybe know some of these conversions and how it's not necessarily the easiest thing to use unless you have one of these nifty little containers that has all these different conversions from quarts to pints and cups and ounces and all that kind of stuff. We'll practice one last time. So say you want to feel, maybe I want to feel a little bit better about myself, so I tell them how much I weigh in kilograms. So using a conversion factor that takes you from pounds to kilograms, 1 kilogram is equal to 2.2 pounds. Let's say I weigh 225 pounds. I don't. But I want to tell somebody how much I weighed in kilograms. So see if you could set up your bridge relating pounds into kilograms. Remember, we could set this up in 2 different ways. We can make fractions out of 2 different ways. I can put kgs on top over 2.2 pounds, or I can flip it around. 2.2 pounds, 1 kg. Hopefully you can see that I would have to use this one here. And lay pounds cancels off. And now it's multiply across the top, divide by the bottom, and you would end up getting about 102 kilograms. Thanks for watching. You can go back and view this as many times as you want. Again, send me a video, or an email telling me that you watched this clip plus a couple other ones, and then I will put in attendance by the end of the week so that we can be accounted for and not get in trouble on either end. Thanks for watching. Have a good day.